Hello, my name is Mr. Barnes. This video was created in order to help you make polynomial animations. Let's get started. Here we are at Desmos.com. You need to go there. If at any time I'm going too fast, which I probably will, feel free to pause the video. And remember, as we're doing this, this is all about making rules and then breaking them. The best artists, in my opinion, are the ones that broke rules. So let me show you a couple of the ones I've been working on. This is where I started. It's not bad, right? So I took away the axes because I think it distracts from what is really going on here. This is my first one. This is my second one, my favorite. And I put in some rational functions here as well. I like how the colors combine. And I'll show you how to do that at the end. That's cool. And this is one I just made up yesterday to practice making for this video. I like this one as well. I like how the rounded rectangle-ish things interact with each other. And a lot of these it's just accidental luck. So allow yourself to make some art that you don't like and then tweak it until you do. So just because you don't like something at first doesn't mean it can't turn into something beautiful. All right, let's start fresh though, shall we? New graph. Blink. This is how I start with a y equals. You can't put an f of x, unfortunately, which is unfortunate. By definition. So I'm just going to put in some, let's see, linear factors here. You could do this in standard form, but you can't manipulate it as much because now we can put in sliders for each of these roots here, and then we can move them around. But because this is an animation, you can really at any time press play on these things and watch this thing dance all over the place. So let's go a little crazy here. Let's do an x minus d. And then I'll add a slider for that and make that thing go all over the place. I happen to think that going from -10 to +10 is a little too much for these things because you remember we're multiplying all these things here. That could be in essence 10 times 10 times 10 times 10, which would be 10,000 according to my mind calculations. So I usually like to limit these to, -3 to +3. That's where I found most of this. Be pretty satisfying. Not go too crazy all over the place. I tried an animation yesterday that was -1 to +1, and that went fine. But I like the -3 to +3. Still get some interesting shapes there. That's a little more. And see, you can see the roots going back and forth. You can see them going here, but you can actually, if you focus on the roots, they are traveling all over the place. They go this way, they go that way. And if you change the speeds of these, they interact with more interesting patterns. I don't like them to go too fast either. It makes me anxious. So I like to slow them down. So here we go. Here we have an animation of a very slow animation, very soothing, of 4 roots. Of course, you could add more roots. You can do all sorts of stuff. But I want to focus on some symmetries here. In our notes, we talked about transformations quite a bit. Here are the notes right now. And as you can see, if you want to reflect something over the x-axis or the y-axis, you can manipulate this problem to do that. So in order to make those beautiful symmetries that you want to see, what I'm going to do is I'm going to copy and paste. I'm going to copy this boop, and paste this. Boop, and then I'm just going to put a little negative sign right there. Ding, and then we have a symmetrical, it's symmetrical over the x-axis here. It looks nice. But I kind of want this to be symmetrical over the y-axis as well. So I'm going to paste it again, but I'm going to make all the x's negative, just like we did with our transformations. And in order to make it all 4, I'm going to copy and paste that new one, and I'm going to sneak a little -a term there. And then we have this going on. So we're already getting somewhere. It makes me want to take away the axes, and you can do that pretty easily with this little wrench. Take away the grid axis numbers, just so you can really focus on the functions themselves interacting with each other. If you want to, this is what I did. I actually did the inverse of this, which we have not learned about yet. If you want to take the x's and y's and start to switch them, which I'm going to do this, and you'll notice that each of these problems because the sliders, oh, this one isn't playing. There we go. Now it's more interesting. Each of these has the A, B, C, and D variables on it, and the variables all connect to these. So as B changes for one function, it changes for the other functions, and I think that's cool. Now, I want to switch all the x's and y's here. This is called the inverse of the function, which we will learn about next semester. But for right now, you can just copy me. It's a pretty basic idea. Just switch all the x's and y's, and then you get the same idea. It's just going left to right instead of up down. So I'm going to take this and create that symmetry. Here, we'll put a little negative sign for an A term. And we'll switch all the y's to their negatives. And it looks like I copied the negative A term there, so I'm just going to take all that, copy it, take away that negative sign. And I know I'm doing this pretty fast, but when you do this quite a bit, it's the same pattern every time. And feel free to copy my functions here, but the part of the mystery of this is to change it a little bit every time, because you never quite know what Desmos is going to do. I really want to zoom in there. I think there's a lot of cool stuff happening right in the middle there. So I'm going to click on there and drag it. And one thing I've been doing with these kind of animations, I think it's really pretty when these become inequalities, so that you get a layering effect. And so the one rule that I found to make cool inequalities is you make all the, because I like to have a blank space in the center here. So I'm going to have all the positive ones be greater than that. So if there's a positive A term, I'm going to make a greater than sign. And if it's a negative sign, I'm going to make that a less than sign. And let me just take some time to do that, because this one actually takes a lot of concentration for me. I make mistakes on this step quite a bit. So you don't, of course, have to do it this way. I mean, art is all about breaking these rules. I think these are pretty cool right here. I find these lines to be distracting, so you can turn off the lines just by pressing down on this for a couple of seconds, and I turn them off. You can also change the opacity of these by, here, I'll turn off the lines. And the fill, this is at 40%. You can change that to 30% or whatever, but 40% looks pretty nice to me. You can kind of see through it. Also, these colors, I don't like the black is kind of distracting, so usually I switch it to something that's a little prettier. Take off these. So, I mean, that's probably enough to get you started. Try that. So here we go. This is an original artwork piece. And I have a little trophy up here because I've signed in. If you want to join the Global Math Art Contest, that'd be awesome. But you don't necessarily have to. If you feel like your work could be there on the global scale, go for it. This one, I think, looks pretty nice. One thing I've also found, that was pretty, is that if you switch up the x's and the y's here, you create some beautiful rational functions, which we just talked about. So if I just randomly switch this to an x, you start to get some really cool patterns here. So it doesn't need to be totally symmetrical. It could be, some symmetry, some not symmetry, because it can never be chaotic, because we're all focusing on these mathematical principles here. But just a little bit of chaos, I think, is kind of cool. Maybe I'll sneak one of these x's into a y. Whoa. That green color is distracting, though. Let's change that. What this needs is more orange. Let's try that. And I think the hardest part of this is to actually get this dialogue. Just remember, you just got to press down on this for like 3 seconds or something, and it'll show up. There it is. All right. Good luck. Happy problem solving. If you need anything, let me know.